In section 11.1, we're solving quadratic equations by completing the square. Our objectives are to use the square root property to solve quadratic equations by completing the square, and use quadratic equations to solve problems. In these examples, we're going to use the square root property to solve each equation. Let's do a quick review about the square root property. If x squared is equal to c, then x is equal to the positive square root of c, or x is equal to the negative square root of c. Now, if c is greater than 0, then we say that there are two real solutions. If c equals 0, then we say there is one real solution. If c is less than 0, then there are two imaginary solutions. We've got three examples already solved. If x squared equals 25, then x could equal 5, or it could equal negative 5. So there are two solutions. If x squared is equal to 0, you get x equals 0 as one solution. If x squared is equal to negative 81, so c is less than 0, we've got two imaginary solutions. By taking the square root of both sides, we find x is equal to 9i or negative 9i. In example 1, letter A, we have x squared equals 9. By using the square root property, we can solve for x by taking the square root of both sides. When you take the square root of the x that's squared, you need to consider that there's two possible solutions. So we have x equals positive or negative square root of 9, which is 3. So one answer is x equals a positive 3, and the other answer is x equals a negative 3. Written as a solution set, you can write your answers as 3 and negative 3 as a set of the solutions. You can check to make sure both of these work in the original equation by substituting. If we want to check x equals 3, we plug that back into the original equation for x, and we do see that 3 squared equals 9. And to check x equals negative 3, we plug negative 3 back into the original equation, and we also see that negative 3 quantity squared is equal to 9. So we have two solutions to this equation. We use the square root property to solve. In example B, we'll do the same thing. We're going to be taking the square root of both sides. Since we have x squared equals 20, we want to get the x by itself. We're going to take the square root of both sides to get x equals plus or minus the square root of 20. Now, 20 can be simplified. If you simplify the radical, since the square root of 20 can be written as the square root of 4 times 5, and 4 is a perfect square, so we can write our answers as x equals positive and negative 2 square root of 5. Now you still want to check to make sure both of those are solutions by plugging it back into the original equation. If we want to check x equals the positive 2 square root of 5, plug that into the original equation. 2 square root of 5, that entire quantity squared, does equal 20 because you're squaring the 2 to get 4 and squaring the square root of 5 to get 5. 4 times 5 is 20. We also want to check x equals negative 2 square root of 5 by plugging that into the original equation, and you will also see that that is true. So we have two answers here to this equation. X equals a positive 2 square root of 5 and x equals a negative 2 square root of 5. In example C, we have 2x squared plus 72 equals 0. Before we apply the square root property, we want to get the x squared by itself. So we begin by subtracting 72 from both sides of the equation to get 2x squared is equal to negative 72. And then we still want to get rid of that 2 out in front, so we're going to divide both sides by 2 to get x squared is equal to negative 36. Now, since we have x squared by itself, we can apply the square root property, take the square root of the left side and the right side. Remember, in doing the square root property, you want to consider both solutions, the positive and the negative. So x is equal to plus or minus the square root of negative 36. But the square root of a negative is an imaginary number, so we want to write our answers as plus or minus that imaginary number I times the square root of 36, which is 6. So our answer is x equals plus or minus 6i. And of course we want to check that by plugging it back into the original equation for x. 2 times a positive 6i quantity squared plus 72. Since 6i squared is 36 times I squared, and I squared is -1, we do end up with -72 plus 72 equals 0. That one is true. And we also want to check x equals -6i. By plugging it in, you want to double check that the left side does equal the right side. So we find that our two answers are x equals +6i and x equals -6i. In the next three problems, we can apply the square root property since we have a quantity squared isolated on one side. By applying the square root property, we still want to consider both the positive and the negative values. So the first one, the quantity x minus 5 squared equals 25, we're going to take the square root of both sides, and by doing that, we get x minus 5 on the left side and plus or minus the square root of 25, which is 5 on the right side. So we have two possible solutions. We can find the first one by setting x minus 5 equal to +5 and x minus 5 equals -5. By adding 5 to both sides of each one of those equations, we get x equals 10 as a possible solution and x equals 0 as a possible solution. So we want to check both of those by plugging it into the original equation. If we check x equals 10, we get 10 minus 5 quantity squared does equal 25. And x equals 0, when we check that, 0 minus 5 quantity squared also equals 25. So our two solutions are 10 and 0. In example F, we can apply the square root property since the quantity of x plus 3 squared equals 11. And when you take the square root of both sides, consider both the positives and the negatives to get x plus 3 on the left side equals the plus or minus square root of 11. The square root of 11 can't be simplified, so we're going to leave the radical in our answer. And then we want to solve this equation for x. We can set up two separate equations. X plus 3 is equal to the positive square root of 11, or x plus 3 is equal to the negative square root of 11. Then by subtracting 3 from both sides of each one of those equations, we can come up with our solutions. X equals, since the square root of 11 and 3 are not like terms, we can write them side by side as -3 plus the square root of 11 as one solution, and x equals -3 minus the square root of 11 as the other solution. We could put those both together and write our answer as x equals -3 plus or minus square root of 11. Again, you can check each one of those by plugging it back into the original equation. So if we check x equals -3 plus square root of 11 and plug that in, so that's going to give us -3 plus square root of 11 plus 3, all of that in parentheses squared. That's going to equal 11 because the -3 and the +3 will cancel out. And when we check x equals -3 minus the square root of 11 by plugging it into the original equation, we also see that that is true. So we have two solutions here. X equals -3 plus or minus the square root of 11. Let's solve example G, where we can use the square root property since we have the quantity 4x plus 1 squared equals 36. We can then write this, begin solving this by taking the square root of both sides to get 4x plus 1 equals plus or minus 6. Now you could break it up into two separate problems, or we could work through this in combined with a positive and negative 6. So then we can write this as 4x on the left side when we subtract 1 from both sides is equal to -1 plus or minus 6. So then we can then break this up into 4x is equal to the -1 plus 6, which is 5, or 4x is equal to the -1 minus 6, which is -7. And then by dividing both sides of those equations by 4, we get x is equal to 5 over 4, or x is equal to -7 over 4. Again, you want to check both of those answers by plugging it back into the original equation. First, plugging in 5 over 4 for x. That's going to give us 4 times 5 over 4 plus 1, that entire quantity squared, does equal 36. And again, you want to make sure you plug it back into the original equation. And then we plug in the negative 7 over 4 for x. 4 times negative 7 over 4 plus 1. Square that. The 4's will divide out, so you get negative 6 in the parentheses squared also equals 36. So both of these answers are solutions to that original equation. In the next set of examples, we're going to solve each equation by completing the square. There's a 5-step method for solving a quadratic equation in x by completing the square. The first step is if the coefficient of x squared is 1, go on to step 2. Otherwise, you want to divide both sides of the equation by the coefficient of x squared. The second step is to isolate all variable terms on one side of the equation. So anything with an x is going to stay on the left side of the equation. Anything without an x is going to go to the right side. The third step is to complete the square for the resulting binomial by adding the square of half the coefficient of x to both sides of this equation. And then we'll factor the resulting perfect square trinomial and write it as a square of a binomial. And then we're going to use the square root property to solve for x. Let's go through a few examples. Step 1 is already done for us in terms of the coefficient of x is already equal to 1. So step number 1 is done for us. Step number 2 is to isolate all the variable terms on one side of the equation. That's done for us as well. We have x squared plus 4x on one side of the equation, and I like to leave a blank here. We're going to have to complete the square by making it a perfect square trinomial, and then we're going to add something in that blank. And then on the right side we have negative 3, and I'm going to add whatever I add to the left side, I want to add the same thing to the right side. Now the third step is to complete the square by adding the square of half the coefficient of x to both sides. The coefficient of x is 4. We're going to add the square of half of that amount. Half of 4 is 2. So 1/2 of 4 is equal to 2, and then I'm going to square that result to get 4. So I need to add 4 in the space provided to make this a perfect square trinomial. And if I add 4 to the left side of the equation, I'm going to add 4 to the right side of this equation. Now what happens is now you can factor this trinomial, and when you factor, you're looking at the factors of positive 4 that add up to 4, and those factors are x plus 2 and x plus 2, and on the right side you get negative 3 plus 4 is 1. Now whenever you use this method of completing the square, this is always a perfect square trinomial, so your factored form can be written as a binomial squared. So this can be written as the quantity x plus 2 squared equals 1. Now we can use the square root property like in the previous examples. By taking the square root of both sides, we get x plus 2 is equal to the square root of 1. We need to consider both the positive and negative values, so plus or minus 1. Now we solve this equation by subtracting 2 from both sides to get x equals negative 2 plus or minus 1. Now we get our two answers by taking negative 2 plus 1. We get x equals a negative 1, and taking negative 2 minus 1, we get x equals a negative 3. So these are our two solutions to this equation. We use the method of completing the square. And as always, we want to check by plugging those back into the original equation, where if you plug negative 1 into the original equation for x, we get negative 1 squared plus 4 times negative 1. So that's going to be 1 plus a negative 4 does equal a negative 3. So that works out. And then if we check negative 3 quantity squared plus 4 times negative 3, that's 9 minus 12 also equals negative 3. So we know x equals negative 1 or x equals negative 3. They're both solutions to that equation. Now let's do example B. We have x squared minus 2x equals 35. The first step is already done because the coefficient of x squared is equal to 1. And now we also can move on to step 2, where we isolate all variable terms on one side, and that's done for us as well. So x squared minus 2x, and then I like to leave a blank, is equal to 35 and leave a blank. Now step number 3 is to complete the square for the resulting binomial by adding the square of half the coefficient of x. -2 is the coefficient of x. We want to take half of that, which is -1. And then with a -1, we're going to square it to get +1. So we will be adding 1 to make this a perfect square trinomial. Since we're adding 1 to the left side, we are also adding 1 to the right side. And then our equation becomes x squared minus 2x plus 1 on the left side and 36 on the right side. Now notice that the left side is a perfect square trinomial that can be factored. And the factors of +1 that add up to -2 are x minus 1 and x minus 1. In other words, we can write this as x minus 1, that quantity squared equals 36. When using the method of completing the square, you're always going to end up with a perfect trinomial square. Now we can use the square root property by taking the square root of both sides. We get x minus 1 is equal to plus or minus the square root of 36, or 6. So x is equal to, by adding 1 to both sides, we get 1 plus or minus 6. So our solutions are x equals 1 plus 6, which is 7, and x equals 1 minus 6, or -5. You want to check both of those by plugging those values into the original equation. Plugging in 7 first for x, we get 7 squared minus 2 times 7. 49 minus 14 does equal 35. And then plugging in -5 for x, -5 squared minus 2 times -5, that's going to be 25 plus 10, also equals 35. So these two check. We know that we have two solutions to that equation using the method of completing the square. Let's continue to use this method of completing the square to solve this quadratic equation. We have 2x squared minus 5x is equal to 3. Step number 1 is if the coefficient of x squared is equal to 1, go to step 2. Otherwise, we're going to divide both sides of the equation by that coefficient of x squared. So since the coefficient is not 1, we're going to have to do this division step. We're going to divide the left side and the right side of this equation by 2. And then that's going to end up with 2x squared divided by 2 minus 5x divided by 2 is going to equal 3 divided by 2. Or these 2's will divide out, so we get x squared minus 5 over 2x, and I'm going to leave a blank, is equal to 3 over 2. Step number 2 is done for us as well. We isolated all variable terms on one side of the equation. Since we have variables x as the only terms on the left side of the equation, we've done that step. Now the third step is to complete the square for the resulting binomial by adding the square of half the coefficient of x. Well, the coefficient of x is -5 over 2. So if that's the coefficient of x, we want to take half of that. We're going to multiply that by 1/2 to get -5 over 4. But we have to add the square of that, so we take -5 over 4 squared, and that is 25 over 16. We need to add 25 over 16 to both sides of this equation. So now we end up with a perfect square trinomial on the left side of the equation that can be factored. The factors are x minus 5 over 4 times x minus 5 over 4. Those are the factors of 25 over 16 that will add up to -5 over 2. And on the right side, we have 3 over 2 plus 25 over 16. Get a common denominator and add those together to get 49 over 16. So on the left side, I have x minus 5 over 4, that quantity squared equals 49 over 16. Now I'm ready to do step 5, which is to use the square root property. I'm going to take the square root of the left side and the right side, considering both the positive and negative values. the left side, we get x minus 5 over 4 equals plus or minus the square root of 49 over 16, which is 7 over 4. And now we can add 5 over 4 to both sides. So we get x is equal to 5 over 4 plus or minus 7 over 4. If you use the addition there, 5 over 4 plus 7 over 4, that is 12 over 4, which is 3. That's one of our solutions. And if we do the minus 5 over 4 minus 7 over 4, that's going to be minus 2 over 4, which is minus 1/2. So we have two possible solutions here. You certainly want to check to make sure that those are both true by plugging them back into the original equation. Let's check x equals 3. Does 2 times 3 squared minus 5 times 3 equal 3? Well, 3 squared is 9 times 2, that's 18. 18 minus 15 does equal 3, so we know x equals 3 is a solution. And for x equals negative 1/2, does 2 times negative 1/2 squared minus 5 times negative 1/2 equal 3? Well, negative 1/2 squared is 1/4, times 2 is 1/2. Does 1/2 plus 5/2 equal 3? 6/2 does equal 3, so that's also a solution to that equation, using the method of completing the square. In section 11.2, you're going to learn another way, but you do want to practice both techniques until you get them down pat, and then once you're faced with solving a quadratic equation, you will know several different approaches to solving these types of equations. In example H, we have 4x squared minus 16x plus 80 equals 0. We're going to solve using the method of completing the square. Since the coefficient of the x squared is not 1, we're going to have to divide first. We're going to divide everything by 4. And when we do that, we get x squared. 4x squared divided by 4 is just x squared. The 16 divided by 4 is going to be minus 4x. And the 80 divided by 4 is positive 20. Equals 0. Now I'm going to isolate the x variable terms on one side of the equation. So I'm going to write this as x squared minus 4x, and then I'm going to leave a blank. By subtracting 20 from both sides, I get a negative 20 on the right side of the equation. Now I look at the coefficient of the x term, the negative 4. I take half of negative 4 to get negative 2. 1/2 of negative 4 gives me negative 2, and then I take the negative 2 and square it. That's what I'm going to add to both sides of this equation. I'm going to add 4 on the left and add 4 on the right. And then I get this nice little perfect square trinomial here. We can factor this, and the factors are x minus 2 times x minus 2, or we can write it as x minus 2, the entire quantity squared, is equal to negative 16. Now by using the square root property, we can find that x minus 2 is equal to plus or minus the square root of negative 16. But that's an imaginary number, so we can write this as plus or minus 4i. And then by adding 2 to both sides of this equation, we can get our two answers, x equals 2 plus or minus 4i. With one answer as x equals 2 plus 4i, and the other answer is x equals 2 minus 4i. And again, you can check both of those by plugging them into the original equation for x and simplifying, and you would see that both of those are solutions to the quadratic equation. In example I, we have x squared plus x equals negative 1. So the coefficient is already 1, the first step is done. We've already isolated the variables on the left side of the equation. I like to leave a blank here and then figure out what I need to add to make this a perfect square trinomial. I take half of the coefficient of the x, so you're going to take half of 1 to get 1/2, and then you take 1/2 and square it to get 1/4. You're going to need to add 1/4 to the left side of the equation and the right side of the equation. When you do this, it can be factored into this nice trinomial. It's a perfect square trinomial, and the factors are x plus 1/2, the entire quantity squared, is equal to a -1 plus 1/4 or a -3/4. Now we can use the square root property and find that x plus 1/2 is equal to plus or minus, consider both positive and negative values here, of the square root of -3/4. But the square root of -3 is an imaginary number, so that is going to be I times the square root of 3 over 2. And then we can subtract 1/2 from both sides of this equation to get x equals -1/2 plus or minus I times the square root of 3 over 2. So we have two solutions here. X equals a -1/2 plus I square root of 3 over 2, or x equals a -1/2 minus I times the square root of 3 over 2. Again, you can check both of those in the original equation, being careful with checking those imaginary numbers, and you'll find that they both work as solutions in the original equation. Although they're not real numbers, they are still solutions to the quadratic equations. In example 3, we find that the distance s of t in feet traveled by a freely falling object is given by the function s of t equals 16t squared, where t is time in seconds. So the input is your time, and then what you get out is the actual distance that's traveled by an object that is dropped. So you have an object, it drops, and then for each number of seconds you can plug that into the function, and you'll determine the number of feet that the object has fallen. We want to know how long it would take for an object to fall to the ground from 576 feet high. So we want to know how long will it take, how many seconds, before that object falls a total of 576 feet. Since s of t in this case is given our distance, we want to know when the distance is equal to 576 feet. We can solve this equation. 16t squared equals 576 by dividing both sides by 16 to get t squared is equal to 36, and then we can use the square root property. But remember, when taking the square root property, you consider both the positive and negative values. So t is equal to plus or minus 6. So when we're talking about time, it would make sense that t equals 6 seconds. The object would have traveled 576 feet, so it would hit the ground. But the other option, t equals -6 seconds, does not make sense in this particular problem, so we say that's an extraneous solution, and our only solution here is t equals 6 seconds.